Hi, everyone. Sorry for Dennis being late. He is actually a polymath, if you have ever heard the term. He really is one. What we have in front of us is a very quick talk on sort of the state of things. Now, we are the holodeck, right? So this is a registered trademark. Dennis and his experimenters back in the early days of holography here at MIT coined the term and rightly patented it, trademarked it. And so Dennis came to me in the 90s and introduced me to virtual reality caves and started my career in computer graphics. He has a number of different ventures involved with holodecks, and one of them is this joint project where we have evolved the AR for Everyone, which is a low-cost platform for viewing AR and VR using the mobile phone. This is a $9 consumer device, and on scale, they're about $5, right? So when you're a large customer ordering thousands of them or tens of thousands of them, they are very cheap. Please come out and demo it. I should have worn one again. I forget these things. Please come out and demo it. You'll see that it's very performant for its cost, and you can get a lot out of it. What we are doing in this next 2 years, as we move towards 2020, is really expanding the holodeck presence. Part of the holodeck design has been to evolve this headset and the optics behind it. The optics are patent pended, and now a lot of this is Dennis's slides and his work, but I think that he does a lot of sharing and teaching along the way, and so what I'd like to do is just talk to you a little bit about the history, the principal concepts, the problems and solution, and where we are with the AR4, right? So MIT has a rich legacy in holography and AR and VR, and none of that has been lost on Dennis. He has actually been a part of these groups and experienced sort of firsthand the great research and work that's come out of MIT, and he constantly refers back to the inspiration for his work coming from the surrounding area and this as a source point. This is a 210-degree field of view, by the way, done in the 80s by the same man who did the Sword of Damocles. So if anyone has heard John Warner's great talk, you know, Leap Optics had continued to evolve, and they have done some amazing work, and they are still in existence today. This is a pretty badass solution, something that is not really known in the greater world. It's known to the people who are near and dear to the field, but not for the rest of us. This was a panoramic field of view. It was in response to a challenge set forth by, I believe, the Navy, although you can't quote me on that. And this is iScan Technologies working on augmented reality, eye scanning, and here are some of their examples. And these are functioning headsets. This is an AR paradigm. So this stuff is not new, and the thinking is not new. In fact, the thinking is quite old. The thinking and the logic behind this is like simple machines. It works well, and we know it works well, and what we are doing is improving on it, and we are miniaturizing it, and we are making it better. But this Pepper's Ghost is the same as the optic that we are using in our patented device, but it is the majority of approaches, right? And so, you know, Dennis was very clear that he wanted, if he wasn't able to be here to talk about this, that we talked about it as a group. So together, we're going to co-create this talk. There's a couple of different sort of principles around this, right? There's this see-through projection, and forgive me if this is sort of like known to you, but it is also good to set the stage of where our thinking comes from. There are projections with an integrated visor, and that's sort of the meta approach. Then there's the internal reflection approach, which you'll see out on the floor. There are a few HoloLenses and some Magic Leaps. I recommend you try them. These are all awesome devices. And then there are these sort of class of exotic emitters and exotic optics, right? And we're getting into stuff like sort of MEMS material level manufacturing and I'm out of my depth, forget it. And then we have these external cameras, right? And so you guys all know that there is sort of this monoscopic projection, that's how we watch a TV. Then there's the stereoscopic projection, what you see in the Magic Leap or in any of your VR headsets. And then there's holographic stuff, right? And so you're seeing the Microsoft Capture stages coming online. There's a lot of great work over at the MIT Museum on laser scanning and what all that implies, and this sort of like light field imaging, right? So those kind of pieces of terminology, I'm sure Dennis would go into a much greater depth on that. I just wanted to glance on it because what it has led us to understand is there are some amazing opportunities to move optics forward and to really sort of connect the digital representations with the real world around us and create real immersion. And so, you know, some of these challenges and some of the things that we've encountered just using commercial off the shelf, not manufacturing our own products, have been the occlusion and transparency of the object you're faced with versus the world, the participating media that it is scattered through or projected onto, the relative brightness, and then the color depth, right? And so I think if you had caught any of Mike's talk, he started to look at sort of how objects are scanned and represented back through AR, and this is camera-based AR, but it works as well in see-through AR. The next question is these light field images. How does an object, and I use light field very loosely, so please, if you have deep technical on light field, don't hold me to the fire on that one. The idea that an object has a certain quality of rendering of light, this chair is going to render a certain way based on the ambient environment. How do we start to bring those ambient environments into our digital facsimiles so they seem more fit for purpose? These are big questions. Right now, what we're dealing with is we're projecting from a light source. In all of these cases, we're projecting a light source onto a participating medium, and then we're having this transmitted experience. And so there are these really amazing things that happen with color, depth, and the eye. And they are not trivial. But they are, again, these sort of, I want to call them simple machines, again, because I bias towards hyperbole and a very sort of like layman's interpretation of things. This is some deep stuff, what you can do with color and rendering when a gray is next to another gray. Now that challenge gets magnified even further as we enter into full color depth rendering. We want to render a motion image and animation or data floating, or we have just-in-time information that needs to be presented and held accountable for. Those are really serious considerations, and there is a lot to learn just from the simple experiments done by groups like Professor Adelson, right? So, well, now, solutions to fusion and occlusion, and what we're really looking for is the ability to vary the occlusion of an object with the ambient view, right? So I want my little Link character or my Smurf to sit on your shoulder, and I want it to be like it's there. And so in order to do that, the lens needs to do a certain performance, the image has to do a certain performance, and it has to integrate with the environment. And some of this great work that Niantic has done with the occlusion of images, being able to run behind other images, understanding computationally how to do that inside of a camera-based image is sort of the first step, but there are also these optic considerations, right? Are we going to have pixel-specific displays in, you know, a sort of a metamaterial sense on a lens that then does the occlusion at the same time as it's doing the color index rendering and depth, blacking out the screen for greater color depth, right? You are solid when I look at you. You're not transmissive. So if everything's floating in the air, then everything's floating in the air. Does it really lock down? Does it become that immersive experience I think that we all sort of dream of? None of these are really solutions, but they are postulates and they are where our thinking is, right? So we have some serious slides here that Dennis had me gin up some examples, and I used the Stanford Bunny to try and keep it legacy. So we're really looking at visual accommodation as the dynamic focal length. This is your lens in your eye and how it focuses according to where an object is. Okay, so visual accommodation totally tends to hyperbole. Vergence accommodation, right? Focal distance, these are another consideration. The best is when it all fits together nicely, right? This all sort of works nicely and things are where they feel they need to be and they look right and it's not straining on your eyes, right? So how do we start to work this angle, right? Well, it's going to take some sophisticated hardware. Some of it you'll see out there. Others have not been manufactured yet, and the machines to manufacture them haven't even been manufactured yet. What we have is a very straightforward way to do optics. This is patent pending. We're moving towards a 180-degree field of view in a single panorama, not in stereoscopic, in order to accommodate for wider field of views, more information, more interesting theater-like experiences. Our optics are all front-facing and, are all catadioptic, right? And so they're transmissive and reflective. You can see what we've got. I'm gonna zip through this. There's a little diagram. There's the brightness in different, and some people, so I've tested it really heavily for the last year. We've tested it with lots of kids. They love the shit out of this. And this is the latest design, which is out on the thing, and that's patented. And then now we're moving into a hard hat. And so this will be the sort of next gen of what we're doing. We're also working on content, building very simple and engaging experiences. And we use a lot of sort of like the average tools, right? These are the state of the state. This is what's going on. And love you all. Thank you very much. Bye.